Okay, so section 2.6 is a review from the previous course, completely review. I will not consider it a review, I will do the whole thing. So the title that I would give to this section is Algebra. Kelsey, go ahead, please. Yes, Fancy, what is she?
No, we were just talking about the whole grade thing.
Okay, is there anything I could clarify? No, okay, but if there is something, please let me know. So I would like to call this section Algebra of Functions and Function Composition. Again, this is all these topics were covered in the previous course. When we talk about algebra, we really think of adding, subtracting, multiplying, and dividing. That's what algebra is all about. But this time we're talking about functions. So something must be different, right? So I'm going to ask you next, what do you think about me asking you to clarify what this means? And the next one will be this. And the next one will be this. And the fourth one will be this. So what did I write? This is f plus g of x. So what am I telling you? What am I telling you now when I say f plus g of x? This is just a name. Say it again. How? Exactly. All it means is f of x plus g of x. That's exactly what it means. So the name of this function tells us what to do with f and g. Of course, I should have written given f and g as functions, two functions. That's what I should have written first. My apologies. So given f and g, two functions, we're asked to create this function. Obviously, this must be the sum of the two given functions. Can anyone give us the second one? Obviously, this is the difference of the two functions. Can anyone give us the third one? F of x. Exactly. That's it. Awesome. And can anyone give us the last one? What do you think? Very good. And I'm going to put this time a comma, and I'm going to write if. I didn't do it for the previous three, but I have to do it now. What am I getting at? What am I telling you? Awesome. Thank you, Heather. Why? Because we know that every ratio has to have one satisfied condition. What is that condition? The denominator cannot be 0. Very good. Awesome. Now, here's a question for you. Let's say I have these two functions. And by the way, what if I ask you to find f plus g of -2? We're going to get to that in a moment. What will you say? Yes? F, not multiplied. F of -2, yes? Plus g of -2. Very good. That's what it is for every x value. Perfect. So now I'm creating two functions. I'm going to create one graph defined between 0 and 5. So here's the function. And I'm going to create a graph that has a domain between 10 and 20. Let's say 15 doesn't look right. This is the function g of x, and this is the function f of x. And I'm going to ask you a question. F g of 2. before you look at the graph, I would like you to tell me what it means. Of 2, G of 2. Very good. Now let's look at the graph. What will you say? Is there anything wrong? Is everything okay? Exactly. If G of 2 does not exist because the domain of G is between 10 and 15, then this function does not exist at 2 at least. But actually, the function doesn't exist for any x value. How come? That's my claim, that you cannot, no one can create this product or the sum or the difference or the ratio with these two functions. How come? Give it a shot. That's my claim. My claim is that with using these two functions, no one can add them, subtract, multiply, or divide them. If you agree with me, please say why. If you disagree with me, please say why. Do you agree with me? Okay, do you disagree with me? Yes.
I agree.
Why do you agree, Jason?
Because their domains don't overlap.
Exactly. There is no common domain. There is not one x value that I can plug in the sum, difference, product, or ratio. Not even one. Because function f is defined between 0 and 5, and function g is between 10 and 15. They have nothing in common. I could never add them. Between 0 and 5, only one exists. Between 10 and 15, only the other one exists. So there is no number to plug it in. So this is extremely important, the concept of common domain. That's our next discussion. So common domain. Bless you. If the two domains do not overlap, if there is no common points, there is nothing I can plug in both functions. Okay? So I'm going to pick two functions, or you can give me two functions if you want. Any two functions you can think of, or we can find them in the book in a minute, and for which we are going to find the common domain. We are going to find the domain of f and g, the common domain, domain of the sum, difference, product, ratio, and also create those functions. So would you like to give me two functions, or I will pick them from the book? We are on page, I'll find it. Say it again. We are on page 310. No problem. We're on page 310. And do I pick two functions? Do you give me two functions, or?
Number one.
I'm sorry?
F of x
Yes?
equals 3 parentheses x minus 4.
Right. But I'm looking at problems 31 through 50. Sorry, I didn't mention that. 31 through 50 on page 310.
31.
31. Very good. So we have f of x, which is 2x plus 3. And we have g of x, which is x minus 1. I'm going to beef it up a little bit. Like, for example, I'm going to put a squared in there. Because these are just two linear functions, and there is nothing really. Good. So we want to find the domain of function f. Can anyone tell us what function is function f? What type? Right. Well, what type of function is it? So we can identify it also. Perfect. This is a linear function. What about the second one? G. What type of function is G? We used it before.
Quadratic.
Quadratic. Very good. What is the domain of function G? Correct. Like any polynomial function is defined everywhere. There are no restrictions. There is no square root. There is no domain, nothing. Perfect. So now I'm going to ask you, what is the common domain of these two functions? The common domain of these two functions is, of course. Here's a note. The domain, I should say, of f plus g, f minus g, and fg is always the common domain. I don't have to come back and write it again. So, bless you. The domain of sum, difference, and product. Notice that I haven't mentioned anything about the ratio. I don't know. There is an if in the ratio, so I can include it here till I look at it. Bless you. So, the domain of the sum, difference, and product is always the common domain. So once I have the common domain, I don't have to write the domain of these three functions again. Good. Now I want to determine those. F plus g of x. I have to write the definition. One more time, what does this mean?
It's x.
F of x.
F of x plus g x.
G of x. Okay, very good. So I replace them. 2x plus 3 plus x squared minus 1. I have to rearrange the whole thing in descending order. Can anyone give us the simplified form? Very good. X squared indeed. Plus 2x.
Plus 3
Plus 2. So what does this represent? It represents the sum of the two functions. It represents f plus g. But that's okay. You're right. That's correct too. That's correct too. So f minus g of x. What is the definition? What do I have to write? There is a lot of writing in this section, but I hope you're not going to find it too difficult. No, I have to write the definition first. Very good. And now I'm ready to replace. I have to write minus, and I have to put parentheses, or I distribute in one step. That's fine too. But I have to make sure that I distribute to both terms. So this is 2x plus 3, and then minus x squared and plus 1. Damon, can you see from there?
I see fine, but I just kind of you give me some fast. You're so fast. So brilliant.
That's why I would like you to come. No, that's not the issue. That's why I would like you to come here, because when you do this, you miss another 30 seconds.
I see perfect.
Okay.
I really can. These glasses. Okay, so I got that whole part. FG X. Who's that third line? The line where you start going purple.
This one?
The top line is that second.
It's this. I have to write the definition for this, what we just wrote a few minutes ago.
Oh, I thought you did that. Oh, you dropping down the number G. F of G. G of X. That's what you're doing right here.
I have to determine all functions.
I think the problem is you want to explain every single step why you're doing f minus g of x.
Because that's a definition.
Okay.
Okay.
And then I replace each function. Is that better?
She's got what we're doing next is the subtraction thing, so f minus g of x, then she wrote it out in long form.
Oh.
So it's the f of x minus the g of x. And then she actually substituted what the equations were for the f and the g.
Gotcha.
And then simplified.
Okay.
I have to distribute -1.
Mm-hmm.
So now in descending order, is everyone following?
Mm-hmm.
Yes? Okay. Negative x squared plus 2x. Very good. What is this function? Yes, it's quadratic, but what does it mean? In other words, I'm asking, how did we determine it? The difference. Very good. That's the difference of f and g. Awesome. So now we are moving on to the product. How do I read the product? Fg of x. fg of x. Very good. F of x times g of x. I will replace f of x by 2x plus 3, and I will replace g of x by x squared minus 1. What do I do next? Yes, so please dictate. Cubed. Very good. Plus 3.
X squared.
Very good.
Minus x squared.
So we distributed these two. Now I have to distribute negative 1. Good. So this is it. There is nothing I can do here. It's already arranged in descending order. What does this function represent? How did we obtain it? And the answer is multiplying f and g. Yes, Damon?
No, I have a question. I'm just following the same one.
Okay, very good. So the last one, f over g. And remember, we already determined the domain of these three. We already stated it. It's right here. The domain of the sum, difference, and product is always the common domain, which is this. No question there. Good. So now we are ready to work on the last function, which by definition is, and we have to write the definition every time, of x over g of x. Very good. So I copy 2x plus 3, and I copy x squared minus 1, comma, if what? Right, in this case, very good, awesome. But in this case, exactly, very good. I have to solve this because I need to determine the domain. Good, so how do I solve this equation? First of all, what type is it? So what type is it? Perfect. How many solutions do I have to determine? Very good. I have 4 different methods of solving quadratic equations. Which one is the best option here? Maybe there are 2 who are best option. Say it again. Yeah, I agree. So I move 1 to the other side and take the square root. Remember, I asked from the beginning, how many solutions do we expect? Exactly, that's what I'm getting at. Good, so now we are ready to write the domain of the ratio. From the common domain, I have to remove what? Correct, very good. In interval notation, can anyone give us the domain in interval notation? Say it again. Very good. Negative 1, union. There are infinitely many numbers between negative 1 and 1. I cannot skip those. Very good. Union. That's it. I cannot exclude anything else but negative 1 and 1. So if you jump here, you're excluding infinitely many real numbers. Is that clear? Everyone? Yes, very good. Moving on. Let's look at finding the domain. Find domain for, I'm going to select another function. Let's say 28. 28 on page 310. And the function is g of x equals the square of x minus 3 over x minus 6. If you were to explain how we obtain this function to anybody, knowing math or not knowing anything about math, how would you explain it? How was this function created? It's a ratio of two functions, right? So a function at the top and a function at the bottom, so it must be something like this, correct? It's a ratio of two functions. The top function is the square root of x minus 3, and the bottom function is x minus 6, right? So this is an application, if you want, of why are we doing what we're doing? To create another function, and we did. Good. So let's look at the top. For a moment, don't look at the bottom, just for 1 second. As we know, top and bottom have to have common domain. If they don't, g of x doesn't exist, means nothing. Okay, so what is the condition for existence of the top function? What should I write? So greater than or equal to 0, but I didn't catch the first part, forgive me. I just didn't hear what you said. I'm sorry. I'm not saying it's wrong.
X minus 3.
Awesome. This is the correct answer. The square root will not exist if the quantity under the square root is not greater than or equal to 0. Perfect. Now let's look at the second one. Awesome. Thank you. Second one. What condition will x minus 6 have? Will it have to fulfill? Not equal to 0. Right? It's in the denominator. Right. So then x minus 6 not equal to 0. Very good. These are the two conditions for this function to exist. The top has to exist. It has a square root. The quantity under the square root has to be positive or 0. Now there is a ratio, and as we know, there is an if. Every time I have a ratio, there is an if. Unless the denominator is 5. If the denominator is 5, there is no if, because 5 is not 0. Good. So now let's solve this, and let's solve this. So the first one says x. Very good. And this one says x not equal. Awesome. Perfect. So now let's graph. I'm going to graph this from negative infinity to infinity. As you know, I don't care for units. This is just an illustration of how I find what I'm trying to find. So this is 3 to infinity. This is this interval. 3 to infinity. And this one says not 6. Okay, so somewhere here I have 6. And I will say not 6. So now I'm ready to write the domain of G. What is the domain of G? How do I write it? Yes, bracket 3, comma.
6.
Perfect. Perfect.
Union.
Perfect.
Parentheses. 6.
That's it. It's guaranteed that if you pick x between this and this and this and this, and you plug it in here, you will get an output. It's guaranteed that if you plug in 6, you will not get an output. And it's guaranteed that if you pick a number to the left-hand side of 3, you will not get an output. So for example, if I say plug in 0, you'll say, sorry, I can't. Because 0 minus 3 is the square root of negative 3. That's not a real number. And 0 minus 6, it's okay. It's negative 6, but I have trouble with the top. Any questions on this? Okay, so we looked at 4 different methods of finding new functions by adding, subtracting, multiplying, and dividing 2 functions. There is a 5th one, last one. It's called function composition. And now you're going to give me your problem when we get to this. This is what we're talking about right now, and then we'll work on your problem. Okay, so function composition is not addition, subtraction, multiplication, or division. Nothing of that sort. It's totally different. So what happens if I start with x, a value, and let's say I apply g to it? What do I get? Awesome, thank you, perfect. Now this is a number, right? If this is a function, this is 5, let's assume that I get 10 here. Now, let's say for whatever reason, I want to apply to this number another function, which is a function f. What do I get at the end? F of g of x. This is what we call f comp g of x. So this is the function composition, which is f of g of x. That's the definition. And this is how we read it. F comp g. Notice that it's a totally different mechanism. It has nothing to do with addition, subtraction, multiplication, and division. Now, can I create g comp f? Yes, I can. Can anyone give us what this means? What is the definition? What am I trying to do here with g comp f? What is this? Very good. Indeed, g of f of x. What if I want f comp f? The composite of f with itself. F of x. Good. Now I'm going to come back here because I have a few questions for you. Forget about this for a moment. I have two bubbles here. I have x, I have g, the function that I apply to this number, and the result that I get here as g of x. If this is 5, whatever function you want, I apply g to 5, let's say I get 10. Can anyone tell us what is the name of this set for g? What does this set represent for g? And it has a specific name. Very important, a key word. Give it a try. Good. How do we call that? How do we call the values of x? There is a specific name that we have to use. For any function, the values of x are called? Thank you. So this is indeed the domain of g. Now let's look at the second set. What does the second set represent for g? It has a specific name, keyword. We need to remember that. I know you know it. Thank you. Good. Now forget about this for a moment. Let's look at f. And please tell me, what does this set represent for f?
Domain.
Thank you. Domain of f. So before we talk about this for a second, tell me, do you think that when I create the function composition, do the two functions have to have a common domain? Like when we added, subtracted, multiply, do they have to have a common domain? Absolutely not. The common domain does not come into play here at all. But what has to happen for the function composition to exist? Follow me. I'm not going to test you on this, but I want you to understand it. The range of g and the domain of must work well together. So there is no discussion of common domain. So if g is applied to 0, and let's say I get 5, and f I cannot apply to 5 because f is undefined at 5, the whole thing collapses. Because I can't get here. F comma g does not exist. One more time. If g is applied to 0, I'm making numbers up. If g is applied to 0 and I get 10, but f is undefined at 10, I can never get here. So the range of g and the domain of f must work well together for the chain to exist. Okay? So whatever g brings in, f has to be defined for. Okay? This is just an idea. I want you to understand that there is no concept, there is no need to think in terms of the common domain because there is no such thing here. These two sets have to work well. Range of g and domain of f. This is part of pre-calculus. Well, I'm not going to test you on something like this. If you do find a problem in my math lab, which is possible, let me know. Okay. Let's pick two functions and see how we create the function composition. On the same page, 310. Let's look at 54. So we have f of x, 5x plus 2, and g of x, and I think I probably copied from two different, but that's okay. 5x squared minus 2, doesn't matter. So I think I copied a function from one problem and a function from another, but that's okay. So it's not 54, something I just created on the spot. Okay, so we are asked to find f cum g of x. We are asked to find g cum f of x. We're asked to find f cum g of 0. And we're asked to find g cum f of 2. Again, I just made it up. Because by mistake, I copied one function from a problem and another one from another. Good. So we are given two functions and we are asked to find two functions. One, the composite of f and g, and the other one, the composite of g and f. And once we have them, we're asked to evaluate them at different values. We start with f cum g. Can anyone dictate the definition of f cum g first? I have to write the definition first. F of g of x. Write it down. Write it down. F, okay, I'm going to write it down for you. F of g of x. Better? Perfect. Good. Do not do this. I'm just making a point. This is where I have to start. This function in here is called the inner function, because this is the function I start with first. What do you think f will be called? Of course, it is the outer function. Why? Because it's the last function I apply. So this is called the inner and this is called the outer. Good. So I copy f, and what do I do here? What do I have to write instead of g of x?
fx.
I crossed it out. It was g of x. What do I have to write instead of g of x? Which is? That's it. G of x is 5x squared minus 2. Perfect. Now I stop for a moment and look at f. Remember what f is telling us. I'm going to write it on the side. When you give me this function, this is what I see. F of whatever equals 5 times whatever plus 2. So therefore, f of whatever, we've done this with f of x plus h in the difference quotient. Same idea. So f of whatever is 5 times whatever plus 2. So please dictate.
Of x.
I'm here. 5 times whatever. 5x squared minus 2. This is the whatever plus 2. Are you with me, everyone? Yes? Alexis, are you okay? Okay. So I distribute 25x squared minus 10 plus 2, and this is 25x squared minus 8. What did we accomplish? This. We determined this function. We have it now. Why don't I evaluate it at what value of x?
X is 0.
Very good. I have the function. So f, g of 0 will be
25 into 0 squared minus 8.
So the answer is, we don't plug in 0, we'd say
That's minus 8.
minus 8. Everyone? Okay? Yes? Okay, perfect. Now I would like to, so these are all both done. Now I want to find this, and then I'll find this. So g comp f of x. I must write the definition first. What is it? Yes, please.
I'm sorry, what did you say the result
This one?
It's,
25 times 0 minus 8.
oh, okay.
Is that okay?
Yeah.
Good. G comp f, the definition.
G of f.
Very good. Awesome. You got it. Good. Again, do not cross it out. I'm just trying to make a point. I have g of perfect. Yes, 5x plus 2. Now please dictate. Now I'm looking at g. Here's what I see. G of whatever equals 5 times whatever squared minus 2. Okay, so please dictate.
5.
That's
Yes?
5 into 5x squared.
This is the whatever. This is what I have to plug in. So 5 times,
5x plus 2.
yes, minus 2. Very good. So I'm going to write it down so there are no surprises. This is our contract.
When that was a negative 2.
G of whatever is 5 times whatever squared minus 2. G of whatever is 5 times whatever squared minus 2.
We get the 2 in the 5x plus 2.
This is function f, 5x plus 2.
Oh, I thought that was the other 5x.
That's okay.
Minus 2.
Are we okay?
That's where you got that from.
Yes? Okay, so we have a contract. So please give me the answer.
That's 25
25,
x squared
yes?
plus 20x.
Yes, very good. Plus 20x plus 4, very good, minus 2. Yes. If at this point in time you're still not managing this, you must do it today, because you are going to fall behind. So, any questions? Okay.
Wait, I'm sorry, so like, what did you just say?
If you haven't managed the contract that we signed, you know, it's
the
my
contract,
joke.
okay. But
5
this
weeks
we're
and-
not being tested on, right? Is that what you said?
No.
I thought you said that was in pre-calculus or something.
The domain of the function composition.
Oh, I thought this was like still a part of it.
The domain of the function composition.
Okay,
Because there is a big theory behind it.
okay,
I cannot just show you this.
okay.
No, everything else is part of the course. Very good. So then we have 125x squared plus 100x plus 20 minus 2 is 18. Now we are asked to evaluate this function at 2. So let's evaluate it. I have the function is right there. So g comp f of 2 will be 125 times 4 plus 2 times 100 plus 18. If you want to give me this number, just give me the number and I'll put it in. How much? So,
Oh, sorry.
no.
That's 500, 700.
500, 700, 718. Good. Function decomposition. Let's see what this means first, and then we'll analyze a couple of functions. So when I'm given two functions, I can create the function composition in both directions. I can create the function composition with only one function itself, with itself. But when I'm given two functions, I either have f comma g or g comma f. Now, in function decomposition, I want to go backwards. I want to decompose the function into inner and outer. Inner is the function that I apply first, and outer is the function I apply to the inner. So here's an example. Let's say I have f of x equals x plus 1 to the third power. Let me call this age. I like the notation in your book because they are asking us now, find the inner and find the outer to decompose function h of x into two functions. Okay, here's the thinking behind. Oh, I forgot to. Do you still need me to do that problem? Or is it clear now? I'm sorry, I just said it and then it went away. Do you still need me to do it? Or you want to try it? Or you want to try it? Because we had an example just now. What if you just try it and then we'll work on it together? Okay, sorry. Okay, so so what is the idea here? Here's how I'm thinking. Okay, I'm looking at x plus 1 to the third, and I say, okay, if I want to evaluate this function for whatever my students want me to evaluate it, which portion of the function will I perform first? Power 3? Oh no, I can't get there. It has to wait. What will I do first? And that will be my inner. Imagine you want to evaluate for the 15. Which operation will you perform first? And that will be your inner function.